Hey everyone, I'm Zeynep Yırtıcı. I'm a freshman industrial engineering student at Bilkent University, and today I will be talking about my Physics 102 lab project. The aim of my experiment was to observe Kirchhoff's laws in real-life applications, so I built 3 different circuits and calculated the theoretical value of the current going through one of the resistances. Then I built the circuit in the lab and measured the current going through that one specific resistance and compared my results. Kirchhoff's first rule states that the sum of currents entering a junction equals the sum of currents leaving the junction. So for example, in this case, I3 equals I1 plus I2. Kirchhoff's second rule states that the sum of the changes in potential around any closed loop of a circuit is zero. So for example, in this situation, changes in the potential in both L1 and L2 is zero. I also used Ohm's law to calculate the changes in the potentials. First, I built 3 different circuits, and then I measured the current coming out of the power supply V1, and I measured this current by connecting a multimeter in series right before the resistance R1. I also calculated the theoretical values of this current by using Kirchhoff's laws and Ohm's law. For example, I made these kind of calculations in order to calculate the current in the first sub-experiment. I used the junction rule first and the loop rule the second. I applied this in every sub-experiment and found the theoretical values as in the table shown below. Finally, I built my circuits and conducted my experiments under 3 different potential differences.
Çok hafif bozuksa da bozuk yani.
Aynen bir
Problem
kilo
çok
var. Biz
hafif değil.
mesela onunla ohmluk
Anladım
değerlerle
hocam.
çalışmıştık. Kilo
Tamam,
ise
sıkıntı yok.
ohmluk.
My results came out pretty good. My biggest error rate was 4%, and the biggest cause of these errors was the significant figure count of the multimeter that I used, because it's probably made a lot of roundings in the last figure, so I could have used another multimeter with a more sensitive scale, but I had limited time and space, so I couldn't. We can also see that the expected and measured values are really close from the graphs. While gray lines represent the expected values, black lines represent the measured values. Another thing to pay attention in these graphs is that the slope of the lines give us the resistance of the circuit, and they remained the same throughout each sub-experiment, which was expected because the resistance remained the same in each sub-experiment.